Nabila binti Muhammad Auluddin Auf. The matrix number E2019-102379. Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila binti Muhammad Auluddin Auf. The matrix number E2019-102379. Introduction. Malaysia, with a population of 32.37 million, has one of the highest per capita rates of COVID-19. And as for December 2020, Malaysia has reported more than 2,072 million COVID confirmed cases and 31,000 deaths.
A very good morning to my lecturer and my fellow friends. My name is Lorena Winson. The study design for the material and method is, this journal is concerned with the vaccination in Malaysia, and the sample data were collected based on our topic by referring to the official GitHub website of Malaysia's Ministry of Health, and they recently focused on COVID-19 data. The data of vaccination in Malaysia was collected from February 24th until December 17, 2021. We used the cumulative data that mentioned by our lecturer. The COVID-19 data is about the type of vaccination and side effect based on the dosage taken. There are 4 different types of vaccine taken by people in Malaysia, which is Pfizer, Sinovac, AstraZeneca, and Sinopharm. Our study instrument is the questionnaire, which was adapted from the lecture note chapter 1 until 7. Questions were modified so that it will fix the context of vaccination in Malaysia after discussed with our team. For the statistical analysis, the questionnaire was structured into parameter estimation for 2 population parameters, hypothesis testing between 2 populations, chi-squared, and analysis of variance, correlation, and regression. Furthermore, we have used some of the formulas to solve the questionnaire. As we know, means and variance are very important in statistics. We count the means and variance. All the questions were calculated using alpha 0.05, alpha 0.10, 90% confidence interval, 95% confidence interval. First of all, we find confidence interval for mean, which sigma unknown and more and equal than 30 and less than 30, and also for the proportion in the first question. Secondly, interval estimation between 2 population proportions used to see whether the people from March to April are vaccinated or not. For the third question from chapter 3, we tested hypothesis testing with large sample size, which sigma known, and test the statistic claim about the proportion which n larger than 30. Z-tests for a large sample were used to test the difference between 2 means for the fourth question. Then for the fifth question, which is from chapter 3, we use chi-square goodness of fit to measure how well a sample categorized data fits a hypothesized distribution. We use one-way ANOVA is compare 3 or more means using the F-test for the chapter 6. Last but not least, we also apply graph sketching to differentiate between critical value and the test value and do the calculation step by step.
Assalamualaikum and hi, my name is Nur Farahin Shamimi. So for the next slide, I will discuss about chapter 1, chapter 2 and chapter 4 regarding the vaccination data. For chapter 1, we have learned about parameter estimation. Parameter estimation is a process of using a sample data to estimate the parameters of the selected distribution. In this cumulative vaccination, we have construct some of the parameter estimation as follows. Number 1, confidence interval for mean, which is sigma unknown and n more than 30. Random sample of 35 days from cumulative vaccination in Malaysia were selected. Confidence interval for the population mean is construct, and the sample shown in the table below. We has construct two confident interval. The first one is 90%. We has calculate the X bar, which is equal to 345,863.5 and sigma 439,250.7, and the N, the total sample, is equal to 35, while Z alpha for 2 equal to 1.645. And then we just substitute all the information that we get into this formula. The answer will be 223,727.32 and 467,999.68. Hence, one can say that with 90% confident interval, the true mean of the population is between 223,727.32 and 467,999.68 based on the sample of 35 days from cumulative vaccination in Malaysia. For the 95% confident interval, the calculation just same like before, but we has to change the Z alpha per 2, which is we get from the table Z alpha per 2 equal to 1.960, and the answer will be 200,339.54 and 491,387.46. Number 2, confident interval for mean, which is sigma unknown and n less than 30. The average current cumulative of vaccination in Malaysia for 15 days is shown below. And we has construct two confident interval. The first one is 90%. From the sample, we has found X bar is equal to 54779,984.07. S equal to 186,125,91.64. And N equal to 15. The degree of freedom is 15 minus 1 equal to 14. And we found the critical value, which is T alpha for 2 equal to 1.761. After that, substitute all the information into this formula. And the answer will be 463,170.57 and 6324,2910.70. And then, we can conclude using the statement here. And for the 95% confident interval, the calculation just same, but we have to change the critical value, which is T alpha per 2 that we get from the table is 2.145. The answer will be 444,71649.25 and 650,883.18.82. And we can conclude with the statement below. Number 3, the confident interval for the proportion. To estimate the proportion of people who have vaccination in Malaysia, a random sample of 120 people is selected. There are 95 people who have less than 45 vaccination in their current data. We also construct two confident interval. The first one is 90% confident interval. First, we must find the p hat. The formula is X per n, and 95 divided by 120 and we get 0.79. And next we has to find the Q hat, which is equal, the formula is 1 minus P hat and we get 0.21. And for the Z alpha per 2, we get from the table is 1.645. With that, we just substitute all the information into this formula. And the answer will be 0.729 and 0.851. And we can conclude that one can say with 90% confident interval that the true percentage who has less than 45 vaccination in their current data is between 0.729% and 0.851%. Next, for the 95% confident interval, the calculation just same like 90% confident interval, but we have to change the critical value, which is that alpha per 2 is equal to 196. After that, we get the answer is 0.717 and 0.863. And we can conclude with the statement below. Next is Chapter 2, Parameter Estimation for two population parameters. Parameter estimation between two population parameters is a process of using a sample data to estimate parameter between two population of the selected distribution. In this vaccination in Malaysia among 2021, we have construct some of the parameter estimation as follow. Number 1, interval estimation between two population proportion. We wish to see whether the people from March and April 2021 have vaccination or not. We construct a 95% confident interval for the two population proportion, and the data show in the table below. For the P1 hat, we get 0.57, and the P2 hat, we get 0.43. After that, find the point estimate, which is E, and we get 0.2156. And for the Z alpha per 2, we get 1.96. And lastly, we substitute all the information we get into this formula and get the answer negative 0.08 and 0.36.
So next we are going to see is about chapter 3, which is hypothesis testing. So let's have a look at the question. So a researcher claims that 60% of people has been fully vaccinated. A random sample of 32.4 million people have been selected in an area, and it was found that around 25,005,22,460 people have been fully vaccinated in Malaysia. Is there enough evidence to support the researcher's claim? So let's test it. So the first step is writing a null hypothesis and an alternative hypothesis. So the second step is to find the critical value. So in this case, our critical value is positive negative 1.645. And the third step is computing the test value. So by computing the test value, we are able to get the p value, which is 0.79. It's the p hat value, which is 0.79. The p value is 0.6 and the q value is 0.4. So by using the formula, we get our z value, which is 22.07.6. So that will be our test value. So by comparing the test value and the critical value that we got, the test value is more than the critical value. Hence, the null hypothesis is rejected. So the conclusion that we can make based on this question is that there is not enough evidence to support the researcher's claim that states 60% of people have been fully vaccinated.
The next slide will be chapter 4, which is hypothesis testing between two populations. We has testing the difference between two means using the Z-test for large. The average type of vaccination and their standard deviation for Pfizer 2 and Sinovac 1 is shown in the table below. At alpha equal to 0.05, we wish to see the average type of vaccination in Malaysia during March and April 2021 between Pfizer and Sinovac 1 show a significant difference. For the step 1, state the hypothesis, H null and H1, and the claim at the H1. For the step 2, we must find the critical value. Since alpha is equal to 0.05 and the test is two-tailed, the critical value are plus minus 1.96. Step 3, compute the test value. We have substitute all the information we get in the table slide 1 into this formula, and we get the answer 3.33. Step 4, make the decision. We reject the null hypothesis since test value is larger than critical value. And lastly, we must summarize the result. There is not enough evidence to reject the claim that the means are not equal. Hence, there is significant difference in the rates.
So I would like to present chapter 5, which is chi-square test, and I will test for the goodness fit. As you can see, there is a table here with a sample of 80 days. Below 5,000 is 5, below 10,000 is 5, and below 20,000 is 25, and above 20,000 is 45. Next, the vaccine dose, we will state the hypothesis, which is vaccine dose has no limit per day is the claim, and we will find the critical value, and the critical value that we got with the alpha of 0.05 is 7.815. And after we find the critical value, we will find the test value using a formula, and then as you can see, this formula to get the expected value, and we do the calculation, and the estimate the chi-square is 55. And after that, we will make the decision, which is to reject the null hypothesis since 55 is more than 7.815, as you can see at the diagram below. And to summarize the result, there is not enough evidence to support the claim that vaccine that has no limit per day.
It's presenting about the chapter 6, analysis of variables. Let's have a look. So our question today is a researcher wishes to analyze 4 different types of vaccine taken by people in Malaysia. So the table 1 shows 4 groups of vaccines which are used, which is Pfizer, Sinovac, AstraZeneca, and others. So at a significant difference of 0.10, tests claim that the significant difference in the average type of vaccine used in Malaysia. So let's have a look at how to solve the question. So the step 1 is to write down the null hypothesis and the alternative hypothesis, and the step 2 is to find the critical value. So to find the critical value in this chapter, we have to use the value of k and the value of n. So by referring to the question, the value of k is 4 and the value of n is 20. So moving on to the next step, step 3 is to test the value. So to test the value, we have 4 methods. We have to find the mean and the variance, and we have to find the grade mean, we have to find the between variance, and we have to find the within variance. So I have already found it, and this is my answers. So to find the grade mean, we have to use the formula total x over k. To find the between variance and the within variance, we have to use the formula given. And finally, to find the f-test value, we have to divide the between variance value divided by the within variance value. So we will get 6.689. Step 4 is we have tested, and it is known that the test value is more than the critical value. In this case, we have to reject the null hypothesis. So the step 5 is there is enough evidence to support the claim that there is a significant difference among the groups.
Conclusion, we are safe to say that Malaysia is one of the highest country that give vaccine with 400,000 doses per day, but with 30.5% of citizens of Malaysia but still unvaccinated. That is okay, and I think the vaccination in Malaysia is the very best in this country. Thank you.
In performing our journal about vaccination in Malaysia, we had to take the help and guideline of some respected person who deserve the greatest gratitude, especially a special thanks to Dr. Shalini Melina binti Sharudin, the course instructor of University Pendidikan Sultan Idris, for giving us a good guideline for assignment through giving example templates and numerous consultations. We are grateful to our lecturer whose insightful leadership and knowledge benefited us to complete this journal successfully. Thank you so much for your continuous support and response whenever needed, especially in online testing. Last but not least, our team member Dorina Desmi, Annabelle, Shamimi, and Aisha Nabila have made smart work and give full of cooperation on this journal group assignment, which helps to complete the assignment successfully. We thank all the people who helped directly and indirectly to complete our statistic inference assignment, which is the journal about vaccination in Malaysia.